So this is an introduction part for ANSYS Mechanical APDL. We're going to look things about the menus, tabs, how to work, basic information about the tabs, how this APDL software works. So first we're going to see the utility menu bar, where we can work with the files, see the visibility, change, control. So we have file, select, list, plot, and extract other tabs here. In file, you can just save your file, save as, reshape, put the job name, and change the job name, or resume from the job name where you have saved, or the change the title, directory, and clear a start. We can just clear everything and then start new. We have select here, composing, assembling, list, say areas, plots, plot controls. For simple example, like suppose we have a geometry model, we can see the numbering. After we are discretizing, we divide into the simple models. We have symbols, styles, suppose shapes. Suppose for plot we want to see just the lines. We can see the lines. If you just want to plot the key points, you just get the key points what are needed here. You can work with the area. Here we have a new analysis tab. To start over the new analysis, we have open the file which we have already created. Then we have save analysis, zoom, pan, rotate, these are all features. Then we have image capture and report generator. So these two will be helpful when you want to print out the results we have opted. So here we have a command prompt. Just you can type your command and get results like animation, other stuffs like that. So then we have a toolbar. In toolbar we have just 4 things here. One is save dv, resume dv, quit, power graph. So before diving into this, we just want to go and look over these things. So whenever you go for analysis, we simply do the 5 things here. First we model the geometry, then we discretize in the sense we divide the physical model into simpler models for finite element method or other methods, especially in a finite element method. Then we define the boundary conditions. For a static structure we define loads. For thermal we define temperature or convection, heat, radiation, and these are stuffs. Then we finally go for the solution. Then we go for plotting results. So this for 5 steps. So for every time we are complete with we have done the geometry modeling, we just want to save dv so that it will be useful for further reference, and we can resume the same dv at that point. So suppose you have clear all the data here, right here, sketch, model, everything. If you have saved already the geometry model, you can resume from that point. So the same way we can do 5 steps. For one analysis we can save the data or save the analysis in 5 ways: for modeling, meshing, boundary condition, load, and plotting, so that we can restart the analysis from the point anywhere you want to, like, you want to start over with. Then in this side, on the right side, we have all these tabs are to change the view, rotate, zoom. So here we have a isometric view, then we have oblique view, we have front view, the same way right view and top view, these all things. So if we have fit view does what it does means, suppose you have an enlarged image and you want to fit to the screen, it simply fits there. Then zoom back, zoom in, zoom out. And this one is a pan model, right? Means if you click it, pan model. So we have here pan model right, pan model left, up and down, rotate, x, y, z. So x, y, z, in x, y, z axis you can rotate the geometry. This pan model left does what? Does the geometry will be shifted to left side, it will be shifted to right side, it will be shifted to up and down. Now here we have a preference. In preference we select the discipline you want to work on. You want to work on structural, thermal, ANSYS fluid, magnetic, electrical, and this is the discipline option H method. Basically when for FEM final method we use H method. Now we have preprocessor. Preprocessor deals with this is all three topics for geometric modeling, discretization, and boundary conditions. So what we see here, first we want to set the element type, what a element you want to use. Then we want to put the properties like area of cross section, moment of inertia, density. Density we can put over here in the geometric material model. We can put the Young modulus like structural, linear, elastic, isotropic. We can put the Young modulus and Poisson's ratio here. You can put the density over here. Then we have a section. Suppose we have a section, we have a different cross section, like for beam we may have different cross section among these options. Then we have, after we have created the model, when we want to create the models, then we have create, operate, and delete options. So create, just want to create the things like area, circle, lines, volumes. Then we want to operate like add, delete, subtract. And delete means you want to delete some particular geometry. Then we have a meshing. Meshing deals with the discretization, dividing the object into simpler models. You can go for a default meshing, or you can go for size control methods. You can precisely you can give your size for each elements. Then we have load conditions. So we can define loads. For example, for a structure we can give displacement, force, pressures at the boundary condition. This deals with the boundary conditions. Finally, when we come to solution, we have solution and we solve with this part. After everything, modeling, discretization, meshing, boundary condition, we just solve, and finally we come to the plot results. General post processing. After three models here, pre-processor, then processing, and then general after post processing. So here we want to plot results. So this is an analysis. Okay, this is an analysis for bracket with the plane analysis. We have hole here. This hole is fixed, and this hole has a tapered pressure varying from 500 to 50. So when we get the plot result here, we go for counter. You can get nodal solution, any solution, element type solution. Suppose I want to see the results for a stress, for one binary stress. I click with the on deform, you get the result. Or if you want to plot your result or animate your result, give your frame size and the time delay, and you can see the result in animated form. So leave the comment if you want to know any details.